Yes, yesterday we discussed about the basic principles of stratigraphy, and once again we recapitulate all the things. The order of superposition. Order of superposition means how the layers were formed according to their sequence, and the main stratigraphy, it is speaking about the rocks or layers, how they will be formed as a layer wise in a earth surface. So it is speaking about stratigraphy or historical geology, and it will gives us some principles. So that it is known as a principles of a stratigraphy. And once again, order of superposition means always the older rocks it will be formed in a bottom, and the younger rocks were formed in the top level. So this is a order. According to this order, the rocks it will be formed, and it's a give the time of a deposition, what type of deposition formed, and it's a give the age also. And next one, it is lithological characters. Yes, definitely, it is speaking about the lithological characters also. Suppose if you have an example for Barakar sandstone or Camp sandstone or a Kumbal Slater, etc. and etc. And those which are having the lives also at the time, what type of animals they were lived, and it's giving the information to us. And structure tectonics. Yes, definitely we can say this is based on this structure and tectonics topics. The earth it's always it's having the moving, and it's consisting of different plates, and the plates which are the moved. The moment it is called the tectonic moments, and there is some gap. It will be there, but actually the gap doesn't have any deposition. It is the period it is known as a non-deposition and non-deposition, and it was happened between the two rock formations. The gap it is called unconformity. Unconformity. And one more word, it is also there. It is disconformity. What it is that the disconformity? The formation is a line between the two successive formations, and then there is no visible or breaking. There is no breaking between the two rock formations, and continuously it will be formed, but it doesn't have any mineralization or doesn't have any mineral deposits. So that is the called non-disconformity. And then fossils records. What it is the fossil records? At the time, whatever animals or plants they were lived, and those plants or animals bodies it will be remained, and those which are covered by the other rock formations, and it is giving to the index to us, which were they were lived at the time. So these plants bodies or animals bodies which are remain as a remain as a fossils, and it is giving the clear information to us at the stage of a time. And such these fossils records it's reliable for determining the relative age of a rock formations, and there is a correlation of over a large areas. And some index fossils. In some indexed fossils, actually it is called extinct organisms. They have wide geographical distribution, and which are the restricted up to particular area only, and it is giving the tell particular time of that formation. The best example for this one, graptolites are very dominantly which are distributed in the rock formations in the era in the period of Ordovician, and but they were the completely extinct in the rocks of a Silurian period. And one more best example for trilobites. Trilobites are actually they are dominated in the period of the Cambrian, and when you come into this Varanus lived, it is lower Cambrian. Yesterday we all discussed about this, and fossil assemblages also. the total number of fossils which are preserved in the rocks. Either it will be giving the information to relative of a rock formations and microorganisms. Fossils of microorganisms like a very small parts of small cells like a foraminifera, radiolaria, asteroids, diatoms, pollens, and the other spores which are particularly stored or preserved at the time, and it is giving the information to determine the relative ages of a rock. And some geophysical methods also we have used for determining the ages. There are various types of geophysical methods like a magnetism, seismicity, electrical resistivity, gravity methods also we can use. And particularly if you can see into this is a electrical and gamma ray logging, and it's also giving the clear information about stratigraphic investigations. And then correlation. Correlation, it is a very important aspect in a particular stratigraphy. And it's giving the clear relationship between the rock formations and at the same time what type of deposits were there at the time. At the time, if it is two formations were deposited at the same time, it is called as a homotaxial. And if it is not formed at the same time, it is indicating as a synchronous of that area. And also Indian stratigraphic units. Uh, it's related to the standard stratigraphic units. Actually, we know that the scientists they were opinioned the Earth it was formed in around around 4.6 billion years back, and these events or whatever rock formations which are pages on the Earth's history, and also again the chronostratigraphic, it is giving the clear information of Earth's age and Earth's history, and also it is corresponding to the geological time also. The chronostratigraphy unit, it is divided into the systems. Yesterday I told you it is divided into the systems, again systems into the series into the stages, and the stages into the zones, and also the similarly it is equal into the geological time scale or geological time unit. And again, the geological time unit, it is also divided into the periods into the epochs in the ages into the phases. When you come into this is a standard chronostratigraphic scale. It is not suitable for stratigraphic divisions and for some for unfossilized sparse data also. So that some limitations were there. And when you come into this is the classification, and it is depend on the rock classification that is called it is a lithostratigraphical classification or lithostratigraphical unit. And in this case, based on the rock formations, how they were formed, and we will make a group, and group again, it's going to divide into the formations, and formations it is divided into the member it is divided into the bed. These are all the depend on the formation of a rock. And finally, it is associates. These are all the associated. We are calling that is a super group. Yes, now we have seen geological time units, chronographic time units, and lithostratigraphic units. And finally, geological time scale. The geological time scale, it is giving to the clear information what type of rocks were formed, and what type of animals and plants were lived at the time with respect to the specific time, and with respect to the specific period, and what it is that age, and it's also giving to us And one more thing it is here, uh, actually there is no life when the earth it was formed about around the 4,600 million years. If we go back at the time, there was no life. So that age or era, it is called. It is a Ezoic. It is called Ezoic, and then it is called as a Ezoic. And we can see that at the time it was mentioned around the 4,600 million years, and slowly the earth it was formed. And slowly the earth was formed, and then around the 4,000 million years, between the 4,000 million years and 3,500 million years, the Precambrian the Precambrian era was there. It was again it was divided into the Archaeozoic. Again, it was divided into the Archaeozoic. In the Archaeozoic, actually there is no life, only oxygen, only oxygen. Oxygen was there, and later onwards, slowly proterozoics were developed. Again, the proterozoic it is divided into the three parts. The first one it is lower, second one it is middle, and third one it is upper. The lower proterozoic it was started from 2000, 3,500 million years. The first sedimentary rock formations were seen, and it's consisting of oceans and other continents. And slowly the development was started. Later, 3,200 million years, the first stromatolites and anaerobic bacteria was discovered, and later it will come up to 2,500 million years. And again, a little bit, if you can see into the 2,000 million age, up to upper middle row, upper proterozoic, 1,000 million age, the first microscopic algae, marine algae, and oxygen, it was there, and atmosphere, it was created. Later on, later on, the Paleozoic means it's old age. Paleozoic, it is a old age. In this one, it is divided into the again six categories or periods, or we are calling that is a systems also. And the first one it is Ordovician. The Ordovician again it is divided into the early and late. Around the age it is 500 million years, and it's consisting of abundance of trilobites, graptolites, and rise of cephalopods. Now slowly the cephalopods were generated at this stage, and again come into the Silurian. In the Silurian, the age it was calculated 430 to 440 million years. And again, the graptolites were developed very much, and slowly we come into the disappeared here, and first fish was identified, and later on, now the age it is the period it is Devonian. The Devonian it's also having the three epochs or series. The age is about around 3,395 million years, and here abundance of corals brachiopods, and appearance of land plants. Here, the plants slowly the plants were developing, and here also we can able to identify the amphibians. Yeah, next one it is Carboniferous. In a Carboniferous, again it is divided into the two. The one it is early Carboniferous, it is called as a Mississippian, and second one it is late Peninsulavian. In early Mississippian, the age is around about 345 billion years, and the late Peninsulavian, it is about 320 billion years, and many non-flowering plants. Glassopteris flora dominated. It was dominated in early Mississippian. Trias. One it is early, second one it is middle, third one it is late. The age it is around 280 million years. It has primitive reptiles, and it's a loss of trilobites, and it's a loss in the trilobites. And next is the Triassic. When you come into the Triassic, again it is divided into the first one late. The age is 230 million years. Here the lives of ammonites, reptiles, and amphibians, and abundant of amphibians were recorded. And this is actually belongs to the Mesozoic. Mesozoic means it is a medieval, and the Mesozoic it was divided into the three parts. The first one it is the Triassic, second one it is the Jurassic, third one it is the Cretaceous, and now we have a scene that is the Triassic. Next, coming to the Jurassic. Jurassic it is also divided into the three epochs or series. The age approximately it is recorded as 192 195 million years, and first birds were originated, and flowering plants, flying reptiles, and rise of dinosaurs. And after that, Cretaceous. The Cretaceous is also divided into the two epochs or series. The first one it is early Cretaceous, and second one it is a late Cretaceous. Both were having a age about 136 million years. Now here slowly the dinosaurs are disappeared. The last of ammonites, and here the continuous of rising from flowering plants. And next, coming to this next era or eratum, that is a Cainozoic. Cainozoic recent. It's a divided into the two periods. It's a divided into the periods. One it is a tertiary, and second one it is a quaternary. In a tertiary, again it's two parts. The first one is a Paleocene, second one is a Neocene. Paleocene, again it's a divided into the three epochs or series. One it is a Paleocene, second one it is a Eocene, third one it is a Oligocene. The age about 64 to 65 million years. And here the particularly apes, first placental mammals we have seen, and flowering plants were dominated here. Next one, it is a Neoscene. Neoscene again, it is a divider into the two epochs. One, it is a Miocene. Second one, it is a Pliocene. Age about 2.6 million years. And here, large carnivorous mammals were originated. In again, including with the molluscs were developed. And final period, it is a quaternary. The quaternary again, it is a divide into two types or two epochs. One, it is a Pleistocene. Second one, it is a Holocene. Holocene, it is a considering as a recent age, and the age is about 1.6 million years. Here, the important fossils or events are living animals, and the man he was appeared here, and many mammals were died because of glaciers were generated, and so that reason many of the mammals were died. And this is the total geological time scale, and it is indicating the important fossils when they were generated and when they were extincted their lives. It is showing, and the particularly absolute age of a different rocks. Yes, definitely we can say with the using of a different biological evolutions and how they were form the sediment layers and the rate increasing of salinity in the seas and oceans. And these are not giving the correct information, or these are not giving satisfactory result to us. The Earth, how it was getting the evolution periods at the time. And recently we were used radioactive methods or radioactive decay methods, which are giving uh, about the age of a Earth. So such type of a study we can see in a geochronology. Geochronology. Chronology means it's a study of age, and the age it is related to the Earth. So that the science, the study it is called geochronology. And we can use here the constantly and continuously the radioactive elements in the process of decay, and it's giving the information to us the stable isotope, isotopes of life, and it is a measured the physical parameters like the temperature and the pressure. The each radioactive element reduce their half-life of the quantity, and by the decay of period at the time of it's known as a half-life period of different elements what we are using in the study of isotopes. Radioactive elements like we can use uranium, thorium, rubidium, and it's potassium. It is also, and most of these elements we can use to study of a dating of a Precambrian rocks, and it is giving the information about very long period of half life half life time, Uranium and thorium decay to form a stable isotope, lead and alpha particle minerals having the more than 1% of uranium and thorium. And we can use here the particular minerals of uranium and thorium, like those are uraninite, monazite, zircon, and allanite, which are used for dating in taking into estimation of a life in a Precambrian rocks. And sometimes we can use the potassium argon isotopes also. It is very important method, particularly to identification of uh, rocks like igneous, metamorphic, and sedimentary. Yes, sedimentary rocks which are consisting glauconite, yellowite, and etc. And igneous rocks have the particular the main composition of a potassium feldspars and mica, which are suitable for dating of the rock with the using of these potassium argon isotope. Radium strontium. This method is also widely we are using because of rubidium. It occurs as a trace element in alkali feldspars and in mica. And next one, it is a carbon dating. Carbon dating is playing a very important role, and it is applicable to younger rocks formations. And the ratios were calculated from plant remains also, and which are enclosed to the younger sedimentary rocks. And the carbon dating is very important because sorry, it's uh, yes, the radiometric method is very important and it is very essential tool. Now we are when we are using in a Precambrian stratigraphy. Almost this is a Precambrian rocks. It's generally it's affected repeated cycles of a tectonism because of most of the tectonism was happened here only, and those rocks having the igneous and metamorphic. So that such rocks is containing the more and the more radioactive elements, and which will be dispersed and migrate to one place to the another, one place to another area. It's having very long distance. And again, in the view of samarium, that its a daughter element that is neodymium. These isotopes are using for determination of absolute age of very old rocks. The samarium and the neodymium elements are not affected by any metamorphic process. So that these are the very important elements in dating of or determining of rocks age. And next one, it is the physiographic division of India. Physiography of India. It's almost an expression. It's related to the geological structure, and it's a depend on the lithology also. The Indian subcontinent broadly divided into three regions. Those are the triangular plateau of peninsular India. Second one is the mountain region of Himalayan. It's known as a Exo Peninsula of India. And third one, it is Indo-Gangetic alluvial plains. Here, the peninsular India, it has covering the more and more older to the younger rocks. And it is an ancient plateau exposed for a long denudation and it's resulting into the peneplations. Its mountains are the reluctant type. It's a reverse traverse for of all the most of the part, and it has a number of valleys and it has a number of hills also. When you come into this is a extra peninsular India. It's a consisting of the part from the alpine to Himalayan territory mountain. Yes, the reason it is a folded and it is a over thrusted mountain. These are all it's a formation in the chain of geology to recent origin. And next one, Indo-Gangetic plains. The Indo-Gangetic plains are very broad, and it's a level of expansions. It consisting of a recent alluvium rivers, and it which are the flowing towards the seas. And these plains were developed between the peninsular and extrapeninsular regions, and it is closely related to the Himalayas. Now, if we can see the peninsular India, the peninsular shield is characterized by varied physiographic complex and its association of plateau mountains. It's a widely distribution of drainage patterns, drainages, peneplain ancient folded mountains like batholiths, graben-like valleys, and the coastal plains. The peninsula is exposed in four regions which are having the distinctly different structural geomorphological trends. The southern part of a western Ghats, it's having the north-northwest and south-southeast trend, and also eastern Ghats, it's having the trending northeast southwest. Satpura and Mahadev ranges, which are located in central India. The trend it is the east and west, and also in the central part of India having the Aravalli ranges. These Aravalli ranges from northwestern peninsula, and again it's consisting of the trend it is northeast southwest. The important mountains of a peninsular India are eastern and western Ghats. Vindhyans, Satpuras, and Aravalis. It's elongated graben like valleys in peninsula. Those are Narmada zone, Damodara valleys. The trending is east, west, and Mahanadi, Godavari valleys with having the northwest southeast trend. You come into this is eastern Ghats. The eastern Ghats form of a series which are detached by hills. It's a heterogeneous composition and they which are extended from border of Orissa through the coastal region of Andhra Pradesh. Yes, this is our map of India. You see here, this topmost of this area, this region, not the eastern region. It is indicating the Exo Peninsula, this one, and this mid part of this one. It is the showing is this mid part of this one, and up to here eastern side and western side. The central part it is almost it is indicating the peninsula of India, and this place it was indicating as a Indo-Gangetic plain. Yes, the average elevation is about eastern Ghats, about 800 meters. Shavarai in Salem and Nimagiri in Koraput, its range is about 1500 meters and 1650 meters, and sometimes in some areas the hills rise up to 1550 meters also. The eastern Ghat and western Ghat both they will meet at a place. The place it is called Doddabetta. It is in Nilgiri Hills. The main composition of these eastern Ghats, Condalites, Charnokites, and Migmatites gneisses. The western Ghats are the range it is called as a Sahyadri. Almost it's extended from north south and it's a parallel to the west coast of India. These mountains are running from the Tapti Valley in the north down to the south to Cape Comorin. The length it is about 1600 kilometers and the average elevation ranges between the 1000 to 1300 meters. The Annamudi in Annamalai, it's the highest peak in the Western Ghats. And the Western Ghats, it's located between to the Dharwar in Karnataka, Ratnagiri and it Mumbai, and some maximum it's a composition of a Deccan traps. Why the southern parts is consisting of Archean gneisses, cistes, and Charnokites also. So all the important peninsular rivers like Godavari, Krishna, Kaveri, and their important tributaries originated in Western Ghats only. And some of the familiar places like Triambakeshwar and Mahabaleshwar, In Maharashtra, there are well-known familiar pilgrimage places which are located in a Western Ghats only. And next one, it is Vindhyan Mountains. The Vindhyan Mountains separate the southern India and northern India. These are continuously group of hills which are formed continuously extended from Jobat in Gujarat to Sasaram in Bihar. The mountains have a generally elevation about 450 to 600 meters. Maximum these ranges composition of sandstones and quartzites. The the Vindhyan Mountains from the watershed of central India, from which rises the Narmada, Chambal, Betwa, Tone, Ken, and stone streams were located. Some streams flow into the Ganga and other into the Godavari and into the Mahanadi also. The Satpura Mountains separate the Narmada and Tipati rivers. The Aravalli Mountains across the Rajasthan from northeast to the southwest. It, it separates the arid and semi-desert of Bikaner, Jodhpur, Jaisalmer of west and more fertile region of Udaipur and Jaipur, which are located in the east. And these are composed of rock. Aravallis, Delhi, Vindhyan, which are in belongs to the super group. And next one, it is Exo Peninsula India. The Exo Peninsula India, it is a composition of mainly Himalayan ranges, which are located in the northern part of our India. The Himalayas, it's stretching about 2,400 kilometers from Naga Parbat. It's 8,126 meters. In the west to Namche Barwa, that is 7,756 meters. In the east forms of a accurate mountain belt and a rampart for the Indian subcontinent along its northern margin. Its southern margin is demarcated by Sindhu. Ganga alluvial belt and the northern margin by the Indus suture zone. The width of this belt it varies from the 232 to 320 kilometers, and the average width it is 275 kilometers. And the northern margin around 4,500 meters. The Himalayas broadly classified into the three longitudinal zones. It's a differing one to another into well marked based on the geographical studies and the features. The first one it is the Great Himalayas, Central Himalayas, comprising the zone of high snow and capped with peak which about 140 kilometers from the edge of the plain. This zone is showing the both sedimentary and older metamorphic rocks, which have been intruded by large masses of a granitic terrain. And second one, it is the lesser Himalayas. These lesser Himalayas form an intricate system and have an average width 80 kilometers. It's consisting of a parallel range in Nepal and Punjab, and also it's having the scattered mountains in Kumain. The outer Himalayan intervene between the lesser Himalayan and plains. The width varies from 8 to 50 kilometers. They form a system of foothills. Often it's referred as a Sivalik ranges also. The greater Himalayan zone is composed. It's a continuous series of highly fossiliferous marine sedimentary formations. The central Himalayan zone is consisting of a lesser to or a middle Himalayan together. It's a composition of metamorphic rocks like a cyst and an isis, and it is along with unfossiliferous sedimentary formations. And the outer or sub-Himalayan zone is mainly it's a composition of upper sedimentary deposits. And third one, it is a Indo-Gangetic plain. The Indo-Gangetic plain is deep crustal and it's consisting of quaternary sediments, and the area it is covered about 8,50,000 square kilometers, and it is surrounded by the states of Assam, West Bengal, Bihar, and Uttar Pradesh, including with Haryana and Punjab also. The origin and structure is closely related with the rise of Himalayas and gives to occasional earthquakes in the North India. The plain it is divided into the four shelves separately uh, by the three transverse high heights from the west to east as the Delhi Haridwar Ridge, Faizabad Ridge, and Mongir Sahara Ridge. The four shelves are Punjab shelves, West Uttar Pradesh shelves, East Uttar Pradesh shelf, and West Bengal shelves. The shelves mainly consisting of a Gondwana, Paleogene, Neogene, and Quaternary sediments. The thickness is about 6,000 meters, and it is encountered along the north fringes of Shivalik hills. And these segments contains animal fossils like rhinoceros, hippopotamus, and elpas, etc. Yes, we have seen the different stratigraphic divisions in our India. And against those stratigraphic divisions also there in our India. More than half of the Indian peninsula it is occupied by the gneissic and schistose composition of the rocks, and these rocks are belongs to the particularly most of the formations particularly belongs to the Archean and Petrozoic ages. The Archean basement is set extremely complex of geological history. It is called as a peninsular Indian shield. Yes, it was remained in relative stable. The formation over 2,500 million years ago. It is bounded by the west, south, and east, and present coastal and whatever it's having. It's covering the Penrojoy to recent areas. The main source of these rocks, metallic deposits, and it's lying over the Archean gneiss and cysts or the Purana basins like Kadapa, Kalarki, Bhima, Vindhyan, Pakal, Bastar, and others. These basins are covered by sedimentary rocks of the middle and late Proterozoic age. These rocks are separated from Archean by an unconformity. It is called as a eparchian unconformity. These rocks are exposed in the Kadapa basin of Andhra Pradesh, the Vindhyan basin in Madhya Pradesh, Bihar, Uttar Pradesh, and Rajasthan, Pakal basin of Maharashtra, again Madhya Pradesh, and Telangana. Chhattisgarh basin in Madhya Pradesh and Orissa. Bastar basin, it's restricted up to only Madhya Pradesh. The Gondwana formations are initiated by the continental ice sheets, which covered a large part of the southern hemisphere. The formations of thick coal seams were formed during the period. It is indicative and disappearance of glacial conditions and improvisation of climatic environments. The major exposures are found in a large faulted crux along the Mahanadi basin. In the Exo Peninsula, the marine sediment systems of Mesozoic and Tertiary groups are predominated. The trunk parts of the sub-Himalayans and the main axis of the Himalayas are occupied by ancient metamorphic rocks and intrusive rocks. The major stratigraphical divisions of India here provided. Let us see that. Here it is mentioning recent alluvium and sand dune and soils. The recent ages here, Pleistocene. Pleistocene contains older alluvium, Keravas of Kashmir, and river terraces. Miocleocene It contains Shivalik group, Kadalur, Varkalli, and Rajamandri formation. Oligomyosine, Murray group, Narchi, and Gudge formations. Upper Cretaceous. It's a lower Eocene Deccan troughs and intertropians. Cretaceous, it's a having the Lametta, bog, Umia beds, Trichinopoly formations. Jurassic, Kyoto limestones and Spiti shales. Jurassic of Kutch. Triassic, Mahadeva and Panchat groups. Permian, Jivan formation and lower Gondwanas. Carboniferous, Lipak and Po formations. Talcher group. Devonians are having Muth quartzites. In Silurian period, it's having the Silurian of Himalayan, Ordovician Himalayas. Cambrian period contains a Himanta group. Middle to upper Proterozoic. These having the upper Vindhyans, Karnols, Bhima, and Chhattisgarh. Middle Proterozoic, Karpas and Delhi supergroups, lower Vindhyans, and late arc into the early Proterozoic. It's having the Eastern Ghats. When you go into the late Archeans, Darwar, Singbam, and Aravalis, middle Archeans having the bolder supracrustals that is called as a Sarguru group. These are the stratigraphic divisions of our Indian continent. And next, let us see the Archean group. Wait, I'll show you. Next, coming to the Archean group. In a Archean group, we are going to discussing about the different provinces and successions of Karnataka in a Dharwad success Dharwad, and finally the mineralogical compositions and the mineral wealth of Archeans. Here, the first term it was introduced by the J.D. Dharma, J.D. Dhana. The term of Archean introduced by him. J.D. Dhana was an ancient drug succession explained. The sequences were earlier. It is related to the Ezoic. Ezoic means it's an absence of a life. The succession again it is divided into the two units based on the geological data and geochronological data. And the lower unit is consisting of very highly deformed and metamorphosed rocks, and the term it is called as Archean group. When compared with this one, the upper unit has a less deformed and metamorphosed rock. It is called as a proterozoic group. And the recent studies were indicated that the early Archeans, the land surface was presumably and it's covered by the shallow sea. Some sediments were deposited in these shallow, volcanically active basins in an evaporate environment. Till now, the oldest rocks were dated by the using of isotopic method, and it's gave the age about 3,800 million years of a sediment formation of Greenland and arthogenesis from the slave province of Canada. It's a gave age about 3,960 million years. Based on these data, Archean era extends from 4,000 to 200, 2,500 million years ago. The upper unit of a proterozoic comprises relatively less metamorphosed sandstones, shales, and limestones with intercalations of volcanic rocks and were deposited in the distinct sedimentary basins. And it is occupied by a large area, and the time span is 2,500 to 900 million years. The earliest phase of Earth history it is representing the Archeans, and it is a unrecognizable basement. The Archeans it's having the various proportions of volcanic and sedimentary assemblages, and these assemblages which are having the different belts of inclusions, enclaves in a gneissic terrains. The systems variously it's referred as a supracrustal associations, cyst belts, green belts, Boulder metamorphosed, etc. and etc. Based on the data previously what we have obtained, like a petrological, geochemical, structural, and geochronical investigations, the Indian Peninsula it is having the five Archean provinces. What are those? Let us see. Here again, our India, it is divided into the different cratons like Aravali craton, Bundelkhand craton, Singhbhum craton, Bastar craton, and Darbar craton. And let us see. These five types of Archean provinces. The first one it is Darban province. Second one it is Eastern Katwa provinces. Third one is a Central province. Fourth one is a Singhbhum province. Fifth one is a Aravali province. Darban province or Darbar province. The Darbar province term was introduced by the Robert Bruce Foote. It's for Archean rocks, and also it's consisting of granite and schist. The Dharwad province, it is located in Karnataka state. Later on, Pichamuthu named the entire Dharwad province as a Dharwad Craton. The area it is extended over 350,000 square kilometers in southern India state. The Dharwad rocks occur in several north-northwest, south-southeast trending belts. The granitic gneiss contains a number of enclaves of amphiboles and cysts, which are regarded to relict as the hosts rocks in a large granitic intrusion. And recent studies, it's indicated that cyst inclusions are enclosed. Within the analysis, it's represented the basic igneous rocks and the primitive sedimentary rocks, which are older than the Dharwars in age. The older cyst shows a relatively a high degree of deformation and metamorphism, which is known as a ancient supracrustal enclaves, and it is also called as a Sargur type or a Sargur cystable complex or Sargur group. These Sargur equivalent rocks occurs in a Sargur, Krishnarajpeta, Nuglihalli, Kalyadi, Namanaglanda, and Gatti Posha Halli, Arahalli, Osunapuri in Karnataka. The cystibles of Kolar and Hatti in Karnataka, it contains gold bearing to the older greenstone belts and occur in the eastern part of the Dharwad crater. The high-grade cysts were intruded further by the peninsular gneissic complex, and together they form the basement for the deposition of volcano-sedimentary assemblages, and belongs to the younger greenstone belts. Yes, it is known as a Dharwad supergroup. And there is a angular unconformity is recognized between Sargors and Dharwad. This Dharwad type cystable or Shimoga, Baba Budan, Kudremukh, Chitradur, and Sandur. Sargur cystibles, it can be related with the Kivitans of Canada and other similar greenstone belts elsewhere. The granitic rocks are extensively developed in the eastern part of Dharwad Craton. The time about 2,700 million years to 2,500 million years. Recently named proposed for this group of rocks, it is as a Dharwad batholith. And next one, it is Eastern Ghat province. Eastern Ghat province, the main characteristic, it has a high-grade metamorphism and mainly it's the composition of a condylite, charnoclite, and pegmatite gneisses. These are distributed in two distinct belts. The first belt aligns the east coast of Andhra Pradesh and Orissa over a distance of 900 kilometers. They extend from south of Ongole to Brahmani River in Orissa. And the second belt extends from the Chennai to south part of Cape Himalayan and also western part of Tamil Nadu up to joining Kerala and Karnataka. The Eastern Ghats and the Western Ghats ranges in the Nilagiri Hills. Precambrians of Karnataka. Here the explaining the approximate age in millennials supergroup group and formation or litho units.